Chapter 16, Pharmacy Business Math. So we have the keywords here, and they're going to be really important in this chapter. We will see some of them on the quiz and on the homework, and it will kind of help you understand what we're learning. Pharmacy technicians in retail settings, as well as in hospital settings, may be involved with business calculations. For a business to remain profitable, the net income or net profit from the sales of medications must exceed the cost of doing business. Mathematical calculations include using percentages to determine discounts and markups, as well as addition and subtraction to maintain the necessary inventory par levels. An adequate markup must be in place so the receipts of the business are in excess of the expenses, and the supply of inventory must be adequate to cover demand, but not so excessive that it ties up the cash flow of the business. Monitoring of pricing and inventory, as well as obtaining necessary inventory levels, may be a task for a pharmacy technician. Cash flow of the pharmacy is directly related to the mathematical calculations performed for inventory and profit or loss that are calculated routinely. Therefore, costs of new inventory must be carefully checked each time new stock arrives to be sure they have not changed since the last order. If inventory prices change and the prices for sales are not changed simultaneously, profits will be affected. A pharmacy technician may have a major role in inventory control and reordering, which affects turnover rate and gross and net income and profit. Inventory includes all stock available for sale by a business. Pharmacy take inventory by making a list of all merchandise on hand at a specific time. Controlled drugs are normally inventoried more often than regular medications, depending on the protocol of their particular business and state and federal regulations. A par or reorder level is determined by sales history. For seasonal medications such as antihistamine and flu vaccines, par level may need to be increased at certain times of the year. To maintain the inventory flow and minimize the need for extra shelf space, replacements for medication should be ordered shortly before they are needed for use. So the amount to reorder is equal to the par or reorder level minus the amount in stock. With certain inexpensive or fast-moving items, it may be advantageous to order slightly above par, especially if a deal is being offered on a particular size. With other slower-moving or very expensive items, ordering close to par or waiting to order may be the best idea. This will also depend on how quickly the medication can be delivered to the pharmacy once it is ordered. In many pharmacies, a perpetual inventory is automatically maintained using a computer program. As medication is sold, it is subtracted from the inventory, and when medication is received, it is added to the inventory. With par, periodic, automatic replenishment, restocking occurs on a continual basis because the computer system submits the order to the wholesaler electronically as stock is used or purchased by customers. And let's do example 16.1. Right. Example 16.1, the par level or reorder point for amoxicillin during the winter is 1,500 capsules. Prescriptions for one day show dispensing 750 capsules. The bottle of 1,000 capsules has been opened and appears to be about half full. How many capsules should be ordered? So we're going to take that 1,500 amount, and it said that we have a bottle of 1,000 that appears to be half full. So then we would just take off the 500, which would leave us with 1,000 capsules. Next part says the pharmacy can purchase 100 caps for $25, 50 caps for $95, and 1,000 caps for $156. What is the cost per capsule of each container, size container? So we would do the 25 over 100, and we would basically want to turn this into a decimal. So to do that, we just need to divide the numerator by the denominator. Calculator. So 25 divided by 100 is 25. So it's 25 cents a capsule that way. The next one would be the $95 over 500. So then we would take our 95 and divide it by 500, and that would give us 19 cents. And then the 1,000 capsules for $156. And that gives us 0.156, which we could round up to 16 cents per capsule. So that would be the best deal. And we should order one of the 1,000 count bottles. Inventory turnover rate is the frequency at which inventory is sold and replaced over a specified time period. The turnover rate is important for setting par levels of medication. This number helps the pharmacy determine whether inventory should be increased or decreased, thus controlling the amount of cash that is tied up in inventory. The turnover rate is important for setting par levels of medications. This number helps the pharmacy determine whether inventory should be increased or decreased, thus controlling the amount of cash that is tied up in inventory. Turnover rate is the total value of inventory ordered over a specific time period, such as 1 month, 6 months, or 1 year, divided by the average value of inventory on hand. The formula for turnover rate is as follows. So the inventory turnover rate is equal to total purchases over a given time divided by the average inventory value. And let's do that in example 16.2. Example 16.2, a pharmacy spends 2,450,000 per year for inventory, and the average inventory value is 350,000. So we're going to use our turnover rate or inventory turnover rate. And that is equal to the total purchases over a given time divided by the average inventory value. Sorry, that looks crappy. So we are going to take the $2,450,000 and divide that by 350,000. And that gives us 7 times per year. That's the turnover rate. Overhead is the actual cost of doing business. It includes all costs for the pharmacy, such as salary, licenses, equipment purchases and repairs, depreciation, utilities, telephone, insurance, taxes paid, and rent. Overhead does not include the cost of inventory. To calculate overhead, total all business expenses, excluding inventory. Depreciation is a rate representing the decrease in value of an asset, equipment, building, computer, printer over time. The annual depreciation equals the cost divided by the estimated time of use in years. And let's do example 16.3. Pharmacy purchased a computer for $1,000, which is intended to be useful for 5 years. So this is example 16.3. So we're using our annual depreciation is equal to the cost divided by the estimated time in years. So then we're just going to take our 1,000 and we're going to divide it by 5 years. And that is going to give us $200 per year. So that is the annual depreciation on that computer that we bought for the pharmacy. Example 16.4, a pharmacy spends $12,585 for inventory per week. The salary for all employees are $12,500 per week. Rent is $1,600 per month and utilities cost $800 per month. In addition, the cost for insurance is $1,000 per month and depreciation on equipment is $2,500 per month. Taxes are up $2,400 per month. What is the overhead for 1 week? So we're going to write all this out. So we're gonna do salaries, rent, utilities, insurance, depreciation, taxes, and then we'll have our total overhead. All right, so the salaries were 12,500. The rent was 1,600 per month. So we would do 1,600 divided by 4 weeks. And that would give us $400 per month. The utilities are $200. And we get that by taking the 800 and dividing it by 4, 800 per month. So parentheses. And then the insurance is $250 per month. And that's from the 1,000 divided by 4. The depreciation is $2,500 per month, so we would take that 2,500 and divide it by 4, which would give us 625. And then the taxes are 2,400 per month, so we would divide that by 4, and that would give us 400. And then if we added all this up, we have our 12,500 plus 400 plus 200 plus 250 plus 625 plus 400, which gives us 14,375,000 per week. The selling or retail price is the price at which an item is offered for sale to a customer once a markup is added to the purchase cost. Wholesale acquisition or inventory cost. The selling price is calculated by adding a markup percentage, a percentage of the original purchase cost of the item, which increases the base price to the customer in order to make a profit in business. The amount of the markup is always based on the purchase cost to the pharmacy. The formulas are as follows. The selling retail price is equal to the purchase cost plus the markup, and the markup is equal to the purchase cost times the markup percentage as a decimal. Or if you know the selling price and purchase cost, markup is equal to the selling price minus the purchase cost. And let's do example 16.5. Example 16.5, a pharmacy marks up private pay prescriptions by 35%. What will be charged for a prescription that costs the pharmacy $14.98? So first we need to find out the markup. And we're going to take that $14.98 and we are going to times that by the 35%. But first we have to take the 35%, change it to a decimal by placing it over 100 and then doing 35 divided by 100, which gives us 0.35. And then we're just going to get out our calculator and do 1498 times 0.35, which is going to give us 5.24. So $5.24. And then the selling price is going to be our $14.98 plus the $5.24. Plus is equal to 20.22. So the cost is $20.22. A prescription sells for $35.60 and the cost is $29.90. What is the markup? So this one's super easy. You're just doing the cost or the selling price minus the cost, which is right there. So $35.60 minus that $29.90, which gives us $5.70. That is the markup. The markup percentage or gross margin is calculated by dividing the markup by the cost and then multiplying by 100. Markup percentages provide information about which prescription medications have the greatest profit. The formula is as follows. The markup percentage is equal to the markup over the purchase cost times 100. Since markup is selling price minus purchase cost, the equation can also be written as the markup percentage is equal to the selling price minus the purchase cost divided by the purchase cost times 100. And then let's do example 16.7. Example 16.7, a medication costs the pharmacy $29.90 and is sold for $35.60. What is the markup percentage? So we actually just found out, we need to find the markup first, but we found that out in example 16.6. So we're going to put that here, or knowing our markup is already 570, and to do the percentage, we need to do $5.70 divided by the $29.90 times 100. So that is the markup divided by the cost times 100. Let's get out our calculator. So 570 divided by 29.90 times 100 gives us like 19%. A discount or markdown may be applied to prescriptions, over-the-counter drugs, or other merchandise. The markdown price is calculated by subtracting a discount percentage, a percentage of the original selling price of the item, which lowers the price the customer pays. Discounts and markdowns are used as an incentive to encourage customers to purchase items by realizing a savings on the original cost or retail price. Markdowns and discounts may be in the form of manufacturer's coupons or special discounts for reasons such as senior citizen initiatives. The amount of the discount is always based on the selling retail price, not on the purchase cost of the item. The item must be marked up for sale first, and then a discount can be applied. A discount decreases the selling price. Markup is based on the pharmacy's purchase cost. The formulas for discounts are as followed. The discount amount is equal to the selling price times the discount percentage, and the discounted price is equal to the selling price minus the discounted amount. When discounts are given based on manufacturer or other coupons, the amount of the coupon should be subtracted from the selling price and the coupon placed in the cash drawer to be used at the end of the day to balance the cash drawer. And let's do example 16.8. Example 16.8, a customer has a 15% coupon for a medication that sells for $45. What is the cost of the patient after the use of the discount coupon? And there's a hint, change the percentage to a decimal number for each calculation. So we're taking that 15%, we're going to turn it into a decimal by placing the 15 over 100. And that gives us 0.15. And then we're going to take to find the discount amount, we are going to take the $45 and multiply that by 0.15. Which gives us $6.75. And then we can find the discount price by doing $45 minus $6.75. So $45 minus $6.75, which gives us $38.25. That is the discount price. The gross income, sometimes referred to as gross profit, is the difference in the sales price and the cost of the inventory with no other expenses of the business considered. This usually is calculated for the total income of the business. The gross income is equal to the sales minus the cost of inventory. And then let's do example 16.9. Example 16.9, calculate the gross profit if a pharmacy's sales were 200,000 and the purchases were 175,000. So our gross income is equal to sales. So 200,000 minus the cost of inventory, which was 175,000. And if we get out our calculator, we can just do a simple subtraction problem. Or if you can do it in your head, that's great. And that's 25,000. That is our gross profit. Net income, sometimes referred to as the bottom line or net profit, is the gross profit minus the overhead. It is the difference between the sales and all of the costs related to the business. A positive net income is necessary to remain in business. So the net income is equal to the sales minus the inventory plus overhead. Because sales minus inventory is a gross profit, this can be simplified to the net income is equal to the gross income minus the overhead. And let's do example 16.10. Example 16.10, if the overhead for the store from example 16.9 was 18,000 for the month, what is the net income? So the net income, if you remember back to example 16.9 we just did a minute ago, it was 25,000 was the gross income. And then we are going to minus that by the overhead from the store, which is 18,000. And then we just subtract, which gives us 7,000. Example 16.11, a pharmacy has a monthly sales of 425,000, inventory purchases of 310,000, salaries and wages of 60,000, utilities of 2,500, insurance of 1,100, and maintenance costs of 775. What is the gross income? Sales minus inventory costs. So our 425,000 minus the inventory costs, which was 310,000. So we're going to take out our calculator and do 425,000 minus 310,000, which is going to give us 115,000. And what is the overhead for the month? That's all expenses, including inventory. So we would add our 60,000 for wages, our 2,500 for utilities, plus our insurance, which was 1,100, plus maintenance, which was 775. And 60,000 plus 2,500 plus 1,100 plus 775. That's going to give us 64,375. And then what is the net income? That's our gross income minus overhead. So that's going to be our 115,000 minus our 64,375, which is 50,625. That is our net income. In many instances, insurance companies provide reimbursement based on AWP plus a percentage of AWP, which is noted as AWP plus percent of AWP. In other instances, reimbursement is based on AWP less a percentage of AWP, which is noted as AWP minus percent AWP. Applying a markdown to a prescription uses the same process as offering a discount. Applying a markup is the opposite. To apply a discount, multiply the discount percent in decimal form by the AWP and subtract this discount amount from the AWP. To apply a markup, multiply the markup percentage in decimal form by the AWP and add this markup amount to the AWP. Dispensing fees may vary by insurance company and medication prescribed depending on the contract. The fees are a means of providing reimbursement for overhead expenses. The following formula is used to determine insurance reimbursement. The reimbursement of the prescription is equal to the AWP plus or minus the percentage of AWP allowed plus the dispensing fee. And the reimbursement of the prescription is equal to the AWP plus or minus the AWP percentage plus the dispensing fee. And then let's do example 16.12. Example 16.12, the AWP for a drug is $64 for a 30-day supply. Insurance will pay a 15% markup and the pharmacy charges a $3 dispensing fee. What is the total charge for reimbursement? All right, so reimbursement. So that is going to be the AWP of the drug, which was $64. And then the AWP percentage, remember this 15%, we're going to turn into a decimal by doing 15 divided by 100, which gives us 0.15. So then in this parentheses, I'm going to do $64 multiplied by 0.15, and then we'll add the dispensing fee. All right, so if you remember order of operations from back in school, we need to take care of the multiplication first. So we're going to go 64 times 0.15, the multiplication in the parentheses. And that was 9.6, right? Okay. Then I'm just going to rewrite it for myself. So 64 plus 9.6 plus 3. So 64 plus 9.6 plus 3. So that would be $76.60. Then the profit would be the $76.60 minus the $64, which gives us $12.60 profit. A pharmacy orders 1,000 tablets of medication at the AWP of $112 and takes advantage of the 10% discount offered on invoices paid within 10 days. The AWP for this medication is $140 divided by 1,000 tablets. So, and then we have insurance reimbursement is AWP less minus 5% plus a $5 dispensing fee. Prescription is written for 60 tablets. What is the AWP for 60 tablets? So we're going to take our $140 and put that over our 1,000 tabs. And remember, we want to do 60 tabs. Oops. And how much money is that? So then we would do 1,000x is equal to 140 times 60. So 140 times 60 first, 8,400. We still have 1,000x. We want to get x alone. So 8,400 divided by 1,000 gives us 8.4. So $8.40. And what is the discounted wholesale cost for 1,000 tablets? So that would be the $112 minus the $112 times the 10% discount. Remember, 10 over 100 is equal to 0.10 or 0.1. And if we do that, we are going to take care of that multiplication first. So 112 times 0.1 is going to give us 11.2, $11.20, and then we're going to take the $112 and minus the $11.20. So that is $100.80. Capitation refers to a contract between the pharmacy and the third-party payer to provide medications to the insured patient. Capitation fees, usually paid on a monthly basis, are a set amount of money paid to the pharmacy by a third party for a person, whether the person receives a single prescription, multiple prescriptions, or no prescriptions. All prescriptions presented must be filled, even if the cost exceeds the fee provided to the pharmacy. This type of reimbursement may provide the pharmacy with a loss during a 1-month period, but can provide a profit over several months depending on the individual's prescription cost. So the profit divided by the loss is equal to the capitation fee minus the prescription costs. And let's do example 16.14. Example 16.14, a pharmacy accepts a capitation fee of $225 for a senior citizen who has 4 monthly maintenance prescriptions, most of which are available as generic drugs. The cost for monthly maintenance medication is $9.50 plus $27 plus 65 plus $42, which gives us a grand total of $143.50. What is the pharmacy's profit or loss for a typical month? So we're using that formula, which is the profit divided by loss is equal to the capitation fee minus prescription costs. So we would take the $225 and minus that from the $143.50, and that gives us a profit of $81.50. Retail pharmacies may require technicians to prepare a daily cash flow report to verify that the payments received during the day balance with the amount of money in the cash drawer. This procedure varies for different pharmacies depending on how the store accounts for coupons, credit card payments, and discounts.